Hello. In this video, we will be showing how to use Git along with Construct. We will be using a very basic Git flow strategy, ideal for small projects and a single contributor. We will start by creating a solution in Construct and we will name it Basic Git Flow. We will call the project Simple GUI. Let's keep a note of where the file is going to be stored. And we also want to make sure that this check mark is not checked so that the solution and the project are saved in different locations. Let's click create. And now we're going to add a page and we're going to save. Now we're going to go to Windows Explorer and we are going to open the folder that Construct created in Visual Code. So here's where the folder was created. We are going to right click, click show more options, and click open with code. We can see it created two files in the root directory, a folder with the same name as our project name, and a file with the name of the page we created. Let's now create a README file. In this file, we are going to keep track of what we are doing. Normally, this README file will contain a scope of work or helpful information. For now, we're just going to keep track of every step that we're making. We're going to save it. And now we're going to go to the section of Visual Studio called Source Control, and we're going to hit Initialize Repo. We can see that VS Code shows all the files in the directory and subdirectories that were created by Construct. The areas where these files are shown is called the Git working tree. This is the area. If we hover over the U in one of these files, we can see that it's marked as untracked. We are going to now tell Git to track any change that we make to these files. We do that by clicking the plus sign next to each one of the titles or by clicking the plus sign in the whole changes area. This moves the file from the Git working tree to the Git staging area, also known as the index. Now, if we hover over the A in the file, we can see that Git has marked that as added. We can move one of these files back into the untracked area by just clicking the minus button, which puts us back into the untracked, and clicking the plus button to get us back. Now let's click on one of the files inside the VS Git tool. This is going to launch a diff tool. It's going to show us all the things that change. In this case, it's going to show us all the things that change before to where we are. We can see that, for example, on the README, and we can also see that on the page one that we created. Now let's do a change to page one by adding a button. Let's label the button and save. Now let's also make a change to the README file and save. Now if we head over to the source control, we can see that there's two files that have changed and they're being shown on the Git working directory. If we click on one of the files, let's start with the README, we can see that only the change between the working directory and the staging area is being highlighted. If we do the same thing to page one, we can see that adding a button added all of this information to page one. We can see that trying to understand the changes on page one is very difficult. If we were to run a console command called git diff, we can see the same thing for all the files that changed. And we can see that in the README case, we can see that the button one, the only line that changed. But if we see the changes on page one, we can see all of the changes that construct made when it added that button. These changes are really hard to track and not really human readable or anything that we should be touching. So we are better off telling Git to not give us a line by line history of the lines that change for the files that construct created. So we do that by creating a file called Git attributes and adding the following lines. When we save that and we go to console again and do the same git diff, we will see the readme change right here. But for the page one, we just see a simple entry saying that there is a difference between the two versions of the file. Now, keep in mind that if we go to VS Code and we click on that page one, all of the changes are being shown. This behavior has actually been identified as a bug all the way back to 2022. So maybe someday they will fix it. But for now, just keep that in mind, that you shouldn't be messing around with the files that Construct creates because there's nothing that we can track. One thing to keep in mind, though, is that in the background, Git is just treating that file as an incremental change. So only the things that changed are being saved in the history, and that optimizes the storage in the history area. Now let's add all these modified files back into the staged area. And now let's go back to construct and compile. We're going to hit the compile button and it starts the process. If we go back to VS Code, we immediately see that construct created two folders, while one is the underscore underscore temp and the other one is the output folder. On the underscore underscore temp is where all the transpile code that construct is creating to make the HTML page is being constructed, including the node modules, which are all of the external files that are being downloaded from the internet. And these are tons of files. Eventually, and you can see here that there's all of these files that are being changed. And eventually we're going to see a message from VS Code saying that there are way too many files being changed, and the VS Code is going to move into a subset of all the Git features. So really, we are better off not keeping track of all of these things that change, either because they exist somewhere else, they are transpiled from files that we have created, or they don't actually change at all after we download them. So to do that, we're going to create a file called git ignore. And on that file, we're going to add these lines. Basically, we're telling it to ignore the temp folder, the output folder, and the CSC file, which is really just a file that Construct creates to keep track of when things are being saved and whether or not Construct is open. So the moment that we save on that file, we see that the folder called temp and output grayed out. And this is a VS Code way of telling us that these folders and files are not being tracked. Now, if we go back to the VS Code Git tool, we see, however, that all of those changes are still here. Basically, we just have crashed VS Code. That's what the message was for. So we are better off just closing VS Code at this point and reopen it on that folder. And now when we go back to source control, we only see the things that changed. One interesting thing to see is that the CSC file that we included here didn't gray out. And what is happening here is that we added the CSC file as one of the state changes, and that makes Git track any changes to the file. It actually takes precedence over the Git ignore. So all that we need to do is actually stop tracking changes of that file by moving it back into the working directory. And you see that when I click the minus, it actually is not going to drop into the changes. It's just going to disappear. And when we go back to the file structure, we see the CSC file being grayed out. Okay, so now let's add the git ignore to our stage area. And this is a good place to make our first commit. Commit is another way of telling Git, I am good with my work and I want to track it for posterity. So let's commit using the commit button. But before we do that, let's create a meaningful message of the things that we did during this session. And when we click commit, we're going to see all of the files disappear. In the background, what happened is that all of those files moved to the commit area, and now they're being added to the history. And we can see the history using the git graph extension, and that shows us our commit. We also see who created that commit and when it was made. If we click on it, we can see all of the files that change, in all of them in this case, since all of them are new. And if we click on one of them, we also see the README. Now, interesting enough, if we click on the page one, we see that we are unable to view the difference because this is a binary file. Exactly what happened on the console. And so that shows us that Git graph is respecting the information included on the Git attributes. Okay, so now let's continue our work in Construct by adding one new button. We're going to label it button 2, and we're going to save. We can see that the working tree shows that in this case only page 1 changed, because that's the only difference between what was in the commit and what it is now. If we go to our console and click git diff, we will see that entry that says that page 1 changed, but it's not showing us all line by line like it did before. However, if we go to VS Code and we click on it, we're going to see all the changes and adding a second button created. Okay, so now we are going to go to the README and just add the thing that we just did. And let's contrast that if we go to the README here on the change area, we can see that only that line that changed is being highlighted. And if we do our git diff, we see only that the button 2 is highlighted and of course the other one. Now let's add all of these changes back to the staging area and commit with a meaningful message. And if we go to our history, now we can see that the history is showing us the second commit. Now, if we click on it, we can see that the history is only showing us the things that change, not all of the files like before. And if we click on one of the buttons again, on one of the files again, it is going to show us all the changes that happen between commits. This is a good time to contrast what just happened with what would have happened if we were trying to keep all of these versions in a folder. First, we don't have to give every version of what we're doing a version number. Git is solving that by giving each commit a unique number between commits. Uh, Git is automatically checking who is making those changes, and it's also telling us when those things are being changed. And it's also just keeping track of the things that change, not the whole directory. If we were doing this the folder way, we would have to make a complete copy of the whole folder, which becomes really, really hard since each folder has the whole npm folder with all the node modules that are tons of them, and they never change. And yet we would be making a copy of all of those things that are changing. It's completely inefficient. Another thing that we don't have to do anymore is having to rename the folder name with the version and the name of the developer. So at the end, it would be very hard to figure out just by looking at the folder what actually changed without opening each construct file and seeing the differences. In a large project, this would be next to impossible. Okay, now let's do all of this one more time by adding a page 2 on construct, by adding a widget, and adding a keypad to the widget, and finally adding an asset. We're going to go to page 2 and add both the widget and the image, and then saving. We're going to go to the README, and we are going to track what we just did and save. Now, if we go back to the things that change, we can see the page, the widget, and the asset and the README. So we did a lot in this session. So let's reflect that in the commit message. One line is not enough. So instead, we're just going to click commit by leaving an empty message. And that is going to launch a new text file where we can type all that we want. Notice how the file comes preloaded with all the files that change to help us remember what we did. Now we can write a meaningful message of what we did in this session. This would be next to impossible to try to do with the folder versioning system. Now, once we are satisfied, we save and close the file. That automatically creates the commit. And if we go to our Git graph, we once again see the person that created it, a new commit number. And if we click on the commit, we can see the more meaningful message that we typed. Okay, so now it's the end of the day and it's time to save this in a remote repo. This will let us keep a backup of what we just worked, just in case the PC goes bad or something like that. So let's head over to GitHub and create a new repository. We're going to name the repository with the same name of our solution. And because we are starting the project in our computer and not in GitHub, we need to make sure that this is an uninitialized project in GitHub. And we do that by not adding a README or a git ignore or a license. So now we're just going to follow the instructions to push code from our existing repository. We're going to copy all of the instructions. We're going to head over to VS Code and type them out on the console. And that's going to start the process of pushing all of our changes into the remote repo. So now if we go back to the repo in GitHub and we click refresh, we see all of the changes. We can see that the README that we created shows in front of our page. So if this were a scope of work or details of the project, someone logging into this will know right away about what is going on. Another thing that we can notice is that the temp and the output file are not being pushed. And we also can see the history of our project by seeing all of the commits. And if we click on one of them, for example, we can see the changes between that commit and the previous, for example, here on the README. And notice how GitHub also doesn't respect the Git attribute settings and is showing all the changes line by line. If we were to use another repository, another remote repository like GitLab, and this is just a sample, you will see that GitLab actually gives you a message that says that the file diff was suppressed because there was a Git attribute entry. Okay, so one last time, let's go back to our project and add a page 3. And on this page, we're going to create a D-pad and we're going to save. Let's go back to the README and reflect that change. And we can see the changes on page 3 and on the README. Now we're going to compile. You're going to notice that the compilation is much faster because all of the node files, the npm files, have already been downloaded. And if we go back to VS Code, we can see that even though we compile, nothing is being tracked about all of the stuff that we compile. Just the README at the page 3 show up. So we are going to make our last commit for the project. Now this is the end of our project and we are ready to release. We will mark that by adding a tag to the commit to let us know that this is the last commit for the project and that we are creating a milestone in our project release lifecycle. What we want to add is something that is called an annotated tag, which is a tag that contains a message, a meaningful message about what the release is all about. So we can do that on VS Code by going to Git graph, right clicking on the last commit, and then clicking add tag. We are going to give it a name. This is 1.0.0. And we're going to give it a message, release version. We're going to make sure that it says push to remote so that the tag makes it all the way to GitHub. And we're going to push or sync changes. We can see on our graph that the tag is there. And if we click on it and right click on it and view details, there's the message that we added. And if we go to GitHub, we can see that the new tag has been added along with the new commit. Also notice that because we added a tag, GitHub automatically knows that you're trying to make a release. So it preloads this section here, releases. Let's formalize this release by clicking on create a new release. We're going to choose the tag. We're going to give it a name, release version. We're going to give it some description. And we are going to add a binary to the release. In this case, what we are going to add is the ch5 that was created on our output directory. So we're going to drag it here and we're going to click publish release. And we can see that now we have a release with both the source code zipped and the ch5c. And now we can give this link to the installation team so that they can push the code into the processor. And now we have it nicely tied between the source code and the compile code. Okay, so this concludes the demonstration of a basic Git flow strategy. The pros are it's very straightforward to use. You don't have to deal with merges or branches. We'll talk about that later. The cons about this is that it creates a messy history. Every single commit that we make ends in the history, and we might not want to show that. Uh, so one way to avoid that is to try to minimize the commits using the staging area instead, and just commit at the end of the day or something like that. And it's also not very good for collaborative work. Thank you very much for watching.